value, so I don't have to add any dimensional constraints. We'll lock that line into the appropriate area, but for now we'll leave that. So next thing is we're going to kind of fill in these radii. So there's a radius function. It's kind of buried in here into the tools command. It's called fillet. So fillet, I can specify a value if I know what it is. In this instance, I don't know what that value is yet. If I leave the add dimension checked, when I go to fit this radius, it'll leave a final dimension on, and I can tweak that if I want to. So if I zoom in here and I click one line and I click the other line and hold, I'm still holding the left mouse button. I can move this and drag this into place and then drop in that final radius. So this gives me a value of 30 millimeters. If I want to keep that same value on the other side, I can add in a radius and modify that value. Otherwise, a little trick, if you click specify value, it'll use the last value of the radius that was used. So now when I click and click, it dumps in the same value. So if I'm trying to keep some symmetry or some design intent here and keep everything kind of the same, I can certainly do that using this little trick. So once we've got this basic outline completed, this is the same kind of rules as SolidWorks. If the line is black, it's fully constrained, meaning it's locked down into some type of coordinate system. If it's a blue line, it hasn't been fully defined yet. So one thing I can do is we can fix this now. Pull this out. And then I can start adding dimensional constraints. So right now it says, hey, it's giving me an angle value. Maybe I want these to be parallel. So I can click this line, and then I can control click the other line, and now I can add a parallelism constraint. So you can see I'm starting to tweak this original design that we have and kind of square it up to the world, which is probably more logistically correct for these, if we were to manufacture this. I would ideally want these to be parallel. And we can do the same for these ones as well. These should be parallel. And now let's go back and add some dimensions. So this should give me a height dimension now. And again, if I want, I can override these values. For what we're doing now, we'll just leave it. And maybe I want to add a height value to these radii. And we'll just kind of lock these into a coordinate system. So now everything should be, oops, I over-constrained it here. Sorry about that. So there's our first sketch, and maybe we want to include in one of these hole features. So I know that this square is a hole that goes all the way through. So let's go ahead and add this into this sketch. So now we can use, instead of drawing a series of 4 lines, we can use our rectangle tool. So if I just click 2 of those curves to snap onto, I can modify the rest by just dragging, and it'll automatically snap to those features. And again, we can add reference dimensions if we want to kind of specify where I want this in coordinate space. Let's do height. So now we're fully constrained. So if I modify any of these parameters, it'll update the model and it'll update that final output. All right, so sketch is done. You can exit out of the sketch by hitting the kind of OK. On SolidWorks, it's a check mark, I believe. And now we can show our mesh. So if you look, we've got a nice clean sketch that represents the profile of this part. And now we can extrude this in a direction. So this is getting up to our feature creation part. So if we go back to the model, we have a couple different options. The first 5 group of icons are all solid functions. And then there's a surface group too. So if we're doing surfaces, non-volumetric extrusions, we would use the surface. For this one, we're going to use actual solid. And if any of you guys are SolidWorks guys, one thing you'll notice is that's missing is a cut feature. So in SolidWorks, you have an extruded cut, extruded solid. Inside of DesignX, that cut is actually embedded inside of each one of these features. So you can do it as an extrusion or as a cut. And I'll show you that a little bit later in one of our other features we build. So to extrude this up to a value or to a height, I want to pick the sketch that we're extruding, and then I want to specify a direction. Direction I can flip. Right now it's going the opposite direction. And if I flip that, I can change its value. And we're just going to put this at 20.5. So you can see it's extruding up this whole body, and when I hit OK, there's our final extrusion, including our rectangular cavity there. All right. So once that extrusion is done, I can use some of their simple validation tools. Right now I'm in millimeters. So if I turn on my analysis, what this shows me is a plus and minus deviation back to the scan data. So I could see that this top is not particularly flat. For the purpose of the exercise, we're going to make this flat. So I'm going to kind of average this out. You can see it's a low tolerance in this blue scale, and we're at high tolerance in this this side here, and then we're nice and almost 30 microns. So really tight accuracy in the middle. So we'll call that kind of an average, and that should be good for this particular part. Okay, so another function for sketching, one thing that's, if anybody's doing foundry work or things with draft, the ability to calculate kind of a max or min condition. So we can get an outer limits of something, and there's a function called silhouette when you're building cross sections. And one thing I want to show you is if I hide my solid, this conical feature, if I were to create a sketch, go back to sketch, and mesh sketch, and if I were to move this sketch up, say back to that 6.5 millimeters, where I cut my other one, you can see that sketch does not properly represent that smallest diameter of that cone. So if I were to model this feature, I would be starting off on the wrong path. So what I want to do is I want to get that smallest hole size accurately. So what they have in here is what's called silhouette range. And that silhouette range, this is where this small little arrow comes in. If I pull this arrow, you can see it grabs all the data through this complete volume. So I've got this giant rectangular volume here. And if you notice, it finds the smallest diameter throughout that entire volume. So everything's projected from this view, and you can use this to find the max condition, which is finding the max of this outer perimeter for outside, and then for inside features, it'll find the smallest hole. And this is advantageous if you happen to scan something with a threaded hole. If you don't have a hard gauge, what you can do is run the silhouette, and it'll find that smallest hole size, and from there you can probably calculate drill size for a threaded hole. So let's hit OK. And there's our hole fit perfectly to the smallest diameter of that cone feature. So if I hit circle, and we can fit a circle to that, and all I'm doing is just snapping to that reference curve. You can see it just snapped right to that pink line if I hold my mesh. Very similar to the line function we used earlier. And I'll just hit OK. And X out of the sketch. So now what I want to do is I want to do a extrusion. And I want to extrude this feature up to this specific surface. So there's a series of options when you're building these 3D features. One of them is blind, which is what I use to calculate kind of the height of this. And now that we've got some geometry built, I can actually use that to move this feature to. So I can do up to a specific surface. And you can see it's going all the way up to that specific geometry. And another nice function here is if you wanted to, you can add draft to this particular part. So this draft will, I know it's specifically at 14 degrees, and I can change the draft angle. And this is what I was talking about earlier. I have the option to merge this, which if I did, it would just kind of blend into this 3D feature, but I want to use this as a cut feature. And then when I hit OK, it cuts out of our geometry. So that's kind of the beauty of the silhouette curve, is being able to find that smallest diameter. If I turn on my mesh, I turn on my tolerance, you can see we're getting pretty good fit inside this tolerance. Looks like it's a little bit heavy on one side, so we can tweak that if we want to. So next step we're going to do is also using sketches to create a reference to build other sketches off of. So what I'd like to do is this particular feature here is we're going to do this as a revolve feature instead of an extrusion. We can create this whole profile all in one swoop, swing it around an axis, and then we can get a nice cut from there. So another thing I can do is I can create a, if I wanted to create what I use, I call them reference sketches. And all I'm going to do is just try to find the center of this feature. One thing that's nice about the sketch function is you can see this giant window. I can actually pull this and move this around so it's just singularly focusing on whatever function I want to use. So I'm not grabbing any extra data out in space. So I accept that, and you notice there's no other pink lines, so it's a very concentrated sketch. And I can fit my circle to this, and this is where I want to use construction geometry. So when I fit a circle, if you're not familiar with construction geometry, it's still a feature or a curve, a representative geometry, but it won't be used in an extrusion function. And so the all I'm going to do is use this for a reference to calculate the center line. So I'll hit OK. And now what we have here is a simple 2D sketch, and I can use this now to create a reference feature or reference plane through the center of this feature to create a new sketch. So if I go to my model function and I want to create a new plane, and I want this plane to be offset from this particular plane through the center of this point. And as I pick those two features, it automatically does the calculation saying, hey, I want to use a plane and a point normal to some specific axis. And then we'll just hit OK. So now I've got this nice reference sketch plane. I can come in here and do sketch, mesh sketch, and it's automatically going to use the last plane I have picked, and we'll hit OK. So now I have this nice clean profile. I can steal this point to build a central axis, and that's using what's called the convert entities function, which we'll do in the next sketch that I'm going to do. What that allows me to do is steal geometry from a different sketch I've already created, and it gives me a hard point to reference to. So now what I can do is I can draw central axes, a construction line, and I can build my actual sketch. So I can quickly kind of do what I was talking about earlier. I can quickly snap some lines there. I can trim those out. And I'm just going to create a little bit of a reference slightly bigger than the geometry itself. And this just gives me make sure it intersects past that geometry, so when I do this revolve cut, everything is put in the right place. There's nothing line on line. So there's my profile. I can dimension this if I want to. Again, I can add horizontal or vertical constraints either through double clicking it or right clicking it. Maybe I want this to be vertical. Yeah, let's keep that. And then we'll hit OK. So before, if you notice, all my sketches were in this direction. So you can see we created that reference using another sketch to create a sketch in a different direction. And then we're going to utilize the revolve function. So I go to my model tab. Again, that's where all my 3D features reside. If I do revolve, and I pick this sketch, it's smart enough to know that that construction center line that I built in there for reference is the axial curve that's going to use to swing this thing around 360 degrees. And I can actually modify this if I only want to do a cut, a specific angle value. I can modify it here. This one, obviously, we want to go all the way around. And then I want this to be a cut. So we'll hit OK. Show my solid. And there's my simple revolved sketch. So if I show my mesh, you can see that fits really well. So as we're going along, we're just kind of slowly building this data set. So another thing we can use is once these objects have been created, we can use existing 3D features to steal lines from as a reference. So and what that is, it's also a silhouette function. I'm sorry, the convert entities function. So next thing I want to do is I want to create these pockets. So I've already got a perimeter established in my original 3D model, which is this perimeter here. So we're going to use these entities instead of having to redraw everything, to use it to cut these pockets. So another thing we can do is I need to create a reference that sits on top of these, so I have a plane to sketch from, or I can sketch from this top plane. So one thing we could do is we can create a plane that offsets. That offset value we can offset up to this plane, and we can use that to start our sketch from, which is what we'll do right now. So I can specify offset. I can give it a value. So it's like 13 millimeters is pretty close. And again, we can tweak these if we want to measure the actual value. And just hit OK. So again, the first sketch, we sketch right off this bottom plane. Because we've got a little step here, I want to sketch off this plane, and then we're going to take that material out using a cut. So go back to our sketch. And this is, if you guys have noticed, it's kind of a rinse and repeat. We just take a sketch, extrude a feature, take a sketch, extrude a feature. So I just want to make sure I'm getting a nice clean wall there. And then we'll build our sketches. So using the convert entities, again, we can steal these existing curves. We can take them from another sketch, or we can actually take them off of the 3D geometry. So if I go to convert entities, I can click these 3 lines, hit OK, and now it dumps them into our sketch. So there's some parameters built into this. If I modify this original sketch, and because these are tied to that original sketch, it'll automatically modify these as well. That's where parametrics come into play. So if I hide my solid body, and let's start building these. So we'll just fit basic line, and we'll do a fillet in between those. And I don't want it to use the previous value, so I can uncheck And I click and drag, and it puts it approximately in that same location. Another function, instead of redrawing this, maybe I want these to be an exact mirror of each other. I can use the mirror function. In order to do that, I need to have essentially a mirror plane, or the actual mirror itself. One way to do that is if I click on line. Again, I'll use construction so it doesn't show up in my final output. And DesignX has these snap functionality already built in. So if you notice, if I slide my cursor, my icon will change right when I get to the midpoint, and I can click and draw that line. So this gives me a center line to mirror this geometry about. So I can go to mirror. It asks me to first pick the symmetry line, pick the line, pick the entities. I grab the 3 curves that I want to mirror, and you can see it fits almost perfect. And I can hit OK. And now I can start trimming everything out. So first thing I need to do is I need to make sure everything touches. If I were to trim this corner here, it would blow away this whole line, and I wouldn't be able to trim out this feature. So now we're going to use, instead of the trim, we're going to use the extend function. And extend is just a matter of clicking those lines, and it'll go to its next nearest neighbor. And now everything should be extended to the right curves. And now I can use the trim. Instead of corner, we're going to switch to power trim. And whichever segment I pick, it's going to chop off wherever it intersects another line. So now I've got 2 perfectly mirrored cuts that we're going to make. And I'm okay with that, so let's accept this. And then we'll make our cut. So I know that it goes this direction, and I'll just kind of arbitrarily give it a value above that part to make sure I'm correctly cutting that through. And switch to my cut, and we'll hit OK. And there's my 2 cuts. All right. So I think that's enough for sketch geometry. I can continue. We can build a couple simple features here real quick. And then in other exercises, we'll go over creating rounds, how to export this data, and kind of what to do with it next. So I'll do a couple more features, and then if you guys have any questions, please chime in. So I'm going to use this top reference feature as a sketch plane. I'll do mesh sketch. And we're going to focus on these 2 bosses here. So I'm just going to fit a circle, fit a circle. And then one thing I could do is maybe I want these to be the exact same size. So I double click on one, control click on the other one, and then I want to make these equal radius. So now I've got that basic sketch. I could do model, extrude. And this I want to merge. I want to make sure this all becomes one body. And I got lucky here, 15 millimeters seems to be the correct height. And there's my bosses. And we'll do this rectangular feature. Same thing, we'll build a rectangle. And now this is a good, again, design intent application. There may be, I may want this specific, maybe when this part was manufactured, this feature is in the wrong area. So if I build some simple dimensional values here, and this is where I can start to come in and say, hey, maybe this should be, well, let's say 30 inches long. And maybe this should be 12 inches wide. We're making a manufacturing change. So this is where I can override what's actually there and start building in design intent. And then I can specify, obviously, where it's located. Maybe I want this to be at 80 millimeters. Maybe this should be 60 millimeters. So essentially, I've taken an existing design, I've used it as a reference, and then I've reworked that feature and put it where I want it. And then the same thing I can do in a simple extrusion. I can drop that down to our existing feature, so we're keeping the same height, and then I can merge that in. So any questions you guys have? Anything else you'd like to see? I think this is a good example of kind of how those sketches can be used in a couple different ways. No questions? Okay. If there are any additional questions, I think my email is out there. I can certainly I have a question. What was the name of that feature, the scanning one? Can you be more specific? I guess I don't understand the question. Are you talking about the extrude feature? Oh, mesh. Is it mesh sketch? Here, I'll leave this on the screen so everybody can see. Oh, silhouette? Is silhouette the answer that you're looking for? All right, there you go. All right. Silhouette. There you go. Any other questions? Anything else you guys would like to see regarding sketching? Okay, I think that's good. I appreciate everyone's time, and again, if you guys have questions, please feel free to reach out to us, and I can certainly answer those.
Thank you very much, Greg.
All right, thank you. I appreciate it, guys.
Thanks.
Well,
That's all right.